The graphs of 4 different functions are shown, defined in terms of 8 constants, A, B, C, and so on. Use the graphs to answer the following questions. Okay, so let's just start with this linear one. So I can see this line here. So I can see here that the b, the intercept, is a negative y value. And the m, the slope, is positive since it's sloping, as I move from left to right, it's sloping upward. Okay, and then let's look at maybe this power function here. So on this one, we can see that k is going to be positive because everything is above the x-axis. And the p is, so it kind of looks like a square root function. So maybe it's definitely going to be, since it's concave down, it's going to be less than 1. Well, actually, I can say p is between 0 and 1. And then if I look at maybe this one here, I can see that my q is a positive, that's the y-intercept. Q is positive. And the r, since it's going down like this, r is between 0 and 1. And then the last function is this cosine thing. And so it looks to me like the midline of that is shifted down. Kind of see that? And so that means C is negative. And the A, since it's a cosine, it starts out up and goes down and so on. So that cosine curve is the way it normally is. So that means A is positive. So then I think what we end up with, which of the constants are definitely negative? So the answer there are B and C. And then definitely positive, there's going to be P, M, Q, R, and A. And then which of the constants are greater than 0 but less than 1, that's P and R. Okay. So here, g of x is, combined with f. All right. So f has an amplitude of 3, right? And then we're multiplying it by 2. So that means that the amplitude of g is going to be, the 3 will be multiplied by a 2. So the amplitude of g will be 6. Okay. And then the midline of that, the midline of f was 2. And then you're going to be subtracting 6 off of that. So that's going to be, so the midline was 2, and then I'm going to go down 6. So the midline of k is y equals -4. So I did f had a midline of 2, and then I'm going to shift that down 6 units. So the new midline will be -4. Okay, if p of x equals 1/2 x, what is the period of r of x, which is f of p of x? Okay. All right, so I think I'm going to write down the formula for f first, because f has a period of 4 pi. So f of x is equal to 3 sine of, okay, to have a period of 4 pi, that means, so here's our formula for f. So let's figure out what the b is for f. So for f, b is equal to, so we know that b is the period is equal to 2 pi divided by b. Okay, so so if 4 pi is equal to 2 pi divided by b, then that means b is equal to 1/2 if I solve that for b. Okay, so that's my f of x. So f of x is equal to 3 sine of 1/2 x plus 2. Okay, and so then that means that my p of x is going to be 1/2 x. So my so my r of x is going to be 3 sine of 1/2 times, and I'm going to plug in 1/2 x for that, plus 2. So then r of x is going to be 3 sine of 1/4 x plus 2. Okay, and so the new period for r of x will be, the period will be 2 pi over 1/4, which is going to be 8 pi. So that's the answer here. Let's go back and look at b now that I have a formula for, for f. I can look back at b, and I could see that, so k, oh, whoops, maybe I messed up here. So k of x is going to be 7 times f of x. So 7, ooh, maybe I messed that up. 3 sine of 1/2 x plus 2. Oh, whoops, okay. And then I'm going to do minus 6. Okay, so here I'm going to have 7 times 3, 21 sine of 1/2 x. And then the 7 times 2 is 14. Minus 6. Okay, so 14 minus 6, that's 8. Oh, so then the midline of that is actually 8, not, okay, so I had that wrong. So hang on. Is 8. Okay, so because the k of x is 21 sine of 1/2 x plus 8. Okay, so that's better. And then let's go ahead and check this one. I think the amplitude of that is correct. So g of x is going to be 2 times 3 sine of 1/2 x minus 3 plus 2 and then we're going to do plus 1. So the amplitude, when I multiply those two together, is going to give me 6. So that's correct there. Okay. All right, so the last one says that I have a graph of, okay, I'm going to erase some of this stuff. Okay. So I have a graph here of tangent inverse. Use what I know about tangent to find each of the following. The coordinates of one point on the graph of f that is not 0, 0. Okay, so what do I know about tangent? I know that tangent of pi over 4 is equal to 1. Tangent of pi over 4 is equal to 1. So I know that tangent inverse of 1 is equal to pi over 4. So that is a point. 1 comma pi over 4. Does f have asymptotes? If so, what are they? Well, if I think about the graph of tangent, it has asymptotes at pi over 2 and negative pi over 2. So if I flip it on its side, then here at pi over 2, it should have an asymptote. And here at negative pi over 2, it should have an asymptote. There. So y equals pi over 2, and y equals negative pi over 2. And then what is the limit as x goes to infinity of f of x? Well, as x goes to infinity, that y value is getting closer and closer to pi over 2. And as x goes to negative infinity, as we go this way, the y value is getting closer and closer to negative pi over 2.